Welcome everyone. My name is Randy Kojima, and I'm going to introduce you tonight to the ICD lens design if you weren't already familiar. But beyond that, we're going to also introduce the next lenses in the family of ICD lenses, the ICD 14.5 as well as the ICD Toric. So thank you very much for logging in tonight on behalf of Precision Technology and Paragon Vision Sciences. We have folks from all over the world, and we sure appreciate your time this evening and this morning for many of you. Precision Technology is based in Vancouver, Canada, so if you happen to be outside of Canada and interested in the ICD, simply go to the Paragon website, icdlens.com, and you can click on Locate an Authorized ICD Laboratory. And that way you can find somebody in your area that's able to provide you the lenses. However, if you're in Canada, then Precision Technology is the place to acquire these lenses. Now, very often in practice, we see the same thing. We have this keratoconic patient with a very challenging shape to fit. We can use soft lenses and know almost certainly that we can achieve comfort, but vision is going to be a problem. Or we can go to GPs, corneal GPs, and we can achieve vision, but comfort or fit could be an issue. So how do we somehow bring the two of those together into a technology? And the answer is quite simple. It's go with the scleral lens like the ICD. With a large scleral lens, a vaulting scleral lens, it doesn't move a lot, similar to a soft lens. So the comfort is very, very comparable to what a patient would feel if they were a first-time soft lens wearer. And then, of course, it has GP lens optics, so it should provide very similar vision to what a corneal GP would provide. The only difference might be that a sealed scleral lens isn't going to move a lot like a corneal GP would, so you don't tend to have fluctuating vision with scleral lenses. So I would say that probably best corrected visual acuity with your corneal GPs or your sclerals are going to be similar, but the difference might be how much fluctuation exists. You can imagine a small corneal GP, if it's moving a lot, its optic zone might be crossing the pupil margin, creating some fluctuation in the patient's vision. The ICD lens is a vaulted scleral lens, meaning that it vaults the entire cornea and ideally should vault the limbus before it finally lands down on the sclera. It's not a corneal scleral lens that would share its bearing between the cornea and the sclera. So 100% of the weight and pressure of the lens should be out here on the conge, and we should completely vault what's in the center. So regardless of how asymmetrical, how tilted, how bulging the cornea is, the ICD should completely vault over top of that, like you see here, where it's difficult to make out the pupil, so you know you've got plenty of fluid between lens and cornea. Now, who are the patients that are ideal for ICD lenses? And the ICD stands for irregular corneal design, and really that's what it was designed for. The very challenging shapes like keratoconus, pellucid, post-refractive surgery, and penetrating keratoplasty. So anytime you have a very unusual shaped cornea, then the ICD is probably the lens you want to choose. Being a larger diameter lens, 16.5, that allows for a great deal of area to vault. There's a lot of room underneath that optic zone or the central zones of the lens to clear any weird corneal shape that we might be dealing with. Now let's start with the case. Here's a patient that basically had it all. Keratoconus, had intacts, then had cross-linking, and also, to top it off, has very dry eye, ocular surface disease. You can see the right eye is a little more advanced in the keratoconus than the left eye is. And here's an image of the intact, and then you can see with the OCT that little intact placed in there, which I always find interesting and intriguing. So let's take the corneal topography and determine the right first lens. And you'll notice also that we have the ocular surface disease that gives this patient some pretty severe dry eye. So not only do we have this very steep cone in the neighborhood of 67 diopters, but we're also dealing with a dry eye patient. So the scleral lens might be a good option because we can vault over top of this asymmetry as well as provide a barrier of fluid between lens and cornea and try to ease this patient's symptoms, dry eye symptoms. And that's what we did. We put on the ICD to vault completely over the cornea, create this fluid layer, this ocular bath basically of fluid between lens and cornea, and make the surface much more wettable than it is. And then we align the lens out here in the far periphery, creating stability in the fit, creating centration, and creating comfort. Now ideally, when the lens goes on eye, it should have between 300 and 400 microns of apical clearance on insertion, and that's simply to allow for the normal settling that happens. If you look at the upper image, we have 0.36 millimeters or 360 microns of apical clearance. 4 hours after settling, that has dropped to 290 microns of fluid. So in only 4 hours, we've dropped 70 microns of apical clearance. With the ICD, you're always going to start slightly high, expecting that the lens will sink into the soft conjunctiva, and whatever apical clearance you start with, you're going to have slightly less. Now, having so much clearance is also valuable because we have corneas that have these high and low points. They might be tilted, or in this case, this patient has a bulging cone inferiorly. So we may want slightly more apical clearance to make sure that we're clearing where the elevation of the eye might be much higher. So always shoot for more fluid rather than less. Now we can look out here with the OCT at how the lens should clear and land. And here's the limbus in this area, and you can see your lens vaulting through its optic zone. Then the next zones in the lens bring the lens down into touch with the conch, but we've got this beautiful vault over top of the temporal limbus. And then the same thing on the nasal side. The limbus is somewhere in this area here, and we have this fabulous vault. Of course, here's your contact lens, there's the posterior fluid, and there's our cornea. And what we see in both cases, both nasal and temporal, we've got this vault that exists through the limbus. Now, is it okay to bear on the limbus? And really, it's not clear in the literature. It's not clear by the experts whether it's okay to touch down on the limbus. So many designers, just to be safe, are saying let's steer clear of the limbal stem cells and just completely vault this area and make sure that we won't have any problems with any kind of stem cell disease or issues. Now, if we switch over to the slit lamp, we see a similar story. The lens is vaulting through the cornea, vaulting through the limbus in here, vaulting well onto the conch before it finally lands itself down and spreads its bearing over as broad a surface area as possible. So not only do we see this beautiful limbal vault, but if we look at all these large and small capillaries in here, they all seem to run right past the lens edge. So we've got this very ideal lens to surface relationship. We're not cutting off any of these vessels. Same thing on the nasal side. We see both large and small capillaries just running right past the edge. Exactly what we want to see in a healthy, optimal scleral lens fit. So the ICD is designed to take eyes like this, these bulging grafts, and just vault completely over top. They are also designed to create that fluid layer between lens and cornea when you have ocular surface disease patients that need some kind of relief from their dry eye symptoms. The ICD as a larger lens, a 16.5, can manage almost any of these very asymmetrical surfaces, and that's what it was designed for. The ICD is the irregular corneal design. Now there's three principal zones that you need to be concerned with when you fit vaulted scleral lens, and the ICD is no different. We want to first vault over all the corneal tissue, like you see here. Then we want to vault past the limbus, 360 degrees around if we can, before the lens lands itself down on the sclera, making sure that we're not cutting off any vessels. So apical clearance, limbal clearance, scleral landing without any blanching. Those are the three principal things that we're looking for in every ICD or every vaulted scleral fit. Now, if you have a corneal topographer that measures sagittal depth, or if you have an OCT that can measure the sagittal depth across a 15 millimeter cord, then you can calculate the sagittal depth of ICD that you need. Now, if you don't have one of those tools, then one of the simplest ways to go is consider the condition. Are we dealing with a normal eye? Is it effectively normal K readings, but it's a patient with ocular surface disease? Is it a post-refractive surgery patient? Is it any patient that's more likely to have a lower sagittal depth? If so, then all you do is pull out the 4200 micron lens. I can fit a high percentage of patients with only the 4200 if it's a normal eye, if it's a post-refractive surgery eye, if it's a low sag cornea. However, if it's a keratoconic patient, you're more likely to need at least 200 microns higher. So if you have keratoconus or corneal thinning disorders like pellucid, if it's a corneal transplant but it's not highly bulging, then you could pull out the 4500 lens. And chances are we could fit maybe 80% of patients out there with a 42 or a 45. We might need to go slightly lower, but as a trial, or higher in depth, but as a trial lens, I can probably get away with those two lenses fit on most patients because they're really in the ballpark of the average depths of these conditions. Now, what if you had a bulging transplant or a patient with a higher depth, maybe a tilted graft? Then you'd go up to a 48. In very rare cases, and I haven't needed to do this very often, maybe only a half dozen over the last 4 years, but I might have needed to go to the high depth lenses. And these are the 1980 penetrating keratoplasties where the buttons often sat up very high and proud. Still happens today, but for the most part, we're looking for using these when we have these real bulging conditions like keratoglobus or very high transplants. Otherwise, a 42 and 45 are the two trials you're most likely to use. Notice each trial lens step, and this is true of all the ICD family of lenses, are 100 micron increments higher than the next. So we go from 3,900 microns in depth to 4,000 to 41 to 42 and so on and so forth. Now the first thing that we look at once the trial lens goes on eye is what does the central clearance zone look like? Do we see this vaulting over top of the corneal tissue? With fluorescein instilled, is it difficult to make out eye anatomy? If it is, then we probably have at least enough fluorescein behind the lens. We want it to be on insertion difficult to make out the pupil or the iris. So we should have enough fluid underneath that lens to make that happen. If you see any corneal bearing, you know you need to go higher in elevation. So if we have a 4200 micron lens on eye and it's touching, we should go up by at least 300 microns, maybe 400 microns higher. The next thing we look at is the limbal clearance zone, and what we're hoping to see is that lens vault through the peripheral cornea onto the initial part of the conj before the fluorescein gets squeezed out and the lens actually lands out there. So we're looking for number 2, good limbal clearance. And in the OCT you can see this where we've marked the limbus in this area and the ICD vaults through that area. Notice how there's much more fluid in the center, then the lens is bringing itself back toward the conge, but in between we're hoping to see this area of vault in between, and that's how we attempt to protect the limbal stem cells. Now the last zone in the lens that we're concerned with is the scleral landing zone, and what we're looking for here is that the lens seals itself off 360 degrees, and we're not seeing any cutting off of the vessels, any blanching, any turning the area underneath the edge, underneath the scleral landing zone, white where the vessel supply has been cut off. Now, we talked earlier about shooting for approximately 400 microns of apical clearance, and that allows for the settling of the lens. If you have an OCT, an anterior segment OCT, you can measure this thickness between the back of the lens and the surface of the eye quite accurately. Now, if you don't have an OCT, the optic section or parallel pipette on your slit lamp is the method that you can use to determine the lens thickness being about 300 microns compared to the posterior tear film thickness. Are they approximately equal? We're looking for a similar fluid layer between lens and cornea to what we have as a thickness of our ICD lens. So the ICD lens is 0.3 millimeters thick, or 300 microns, and we want a similar thickness of fluid, maybe slightly more, up to 400 on insertion. Now when you have that high apical clearance in the neighborhood of 300 to 400 microns, that allows you to take an eye shape like this, where we have this bulge in the cornea. We have more fluid in the center, less fluid over the cone, but most importantly we have enough vaulting of that lens above these unusual opacities that we deal with. So making sure that we clear the corneal tissue is the goal, and if you had to err, it's always safer to err on the high side. Now, why err so much on the high side? It's real simple. You know from numerous studies, and these are the 3 that have been done on the ICD. There's other studies done on other lenses that show similar degrees of settling. And in the 2 Pacific University studies, we found approximately 100 microns in the first study. So over an 8-hour period, these lenses settled approximately 100 microns. In a second study, the average settling was found to be about 127 microns. John Mountford in Australia did a much more comprehensive analysis. He took 392 patients, 497 eyes, I believe it was, and measured the clearance on insertion, but then again measured the clearance 30 days after wear. And what he found was, on average, the lenses settled approximately 146 microns, about 150 microns. So if you start with 400 microns of apical clearance and know that it's possible to lose 150 microns, that means that chances are you'll be in the neighborhood of 250 post-settling microns of apical clearance. For instance, in just this 8-hour period, this patient went from 310 microns to only 110 at the apex. But what was the clearance over the inferior cone? That would be the question. So important thing is to make sure that you have enough vault to start with. Always err on the high side. Now, there's been a few studies that have looked at scleral lenses and the amount of oxygen permeability making it through them. And most of the studies that have come out at present are theoretical calculations of oxygen permeability through the plastic. And we know from years and years of vaulted scleral lens fitting with thicknesses of 0.3 millimeters or higher, our patients aren't showing signs of edema. They aren't showing signs of the cornea or tissue being starved of oxygen. In another study at Pacific University, 3 different decays of lenses were placed on patients over each one over an 8-hour period, and the corneal swelling was measured. Even with the lowest DK material, a 65 DK lens in the ICD, the corneal swelling was in the neighborhood of 2.27%. So to put that in perspective, normal overnight corneal swelling is 2.8. So even with the lowest DK, and the ICD is manufactured in the HDS 100 material, plenty of oxygen permeability, we're seeing swelling rates that are, or percentages that are very, very low. So it doesn't appear that you need to be worried about this significant amount of fluid between lens and cornea. Somehow oxygen is getting through there because we're just not seeing patients have problems with vaulted scleral lens, at least as far as oxygen permeability goes. Now, one of those important areas that I personally found is a bit of a mystery in the beginning, and I know from speaking with practitioners that it's a bit of a concern. When do we adjust the limbal clearance of these lenses? Is it okay to have this thing landing itself down? Well, ideally with the ICD, we vault through the limbus. We shouldn't be landing that lens down on the peripheral cornea and limbus. Although this is an even pressure all the way across, the goal is to protect the limbal stem cells, so vaulting over top of that area is important. But we also similarly don't want to be rubbing on the peripheral cornea. That might cause a bit of desiccation, a bit of staining. So our goal is to vault through that area. What we're shooting for is something that looks like this, where you can see the fluorescein bleed past the peripheral cornea, past the limbus, and onto the sclera. That's the goal before the lens lands itself down. Now, it's very common to see this kind of appearance after settling, where you have this nasal superior arc. And we'll talk about this. It has more to do with the slight temporal decentration of the lenses. But on insertion, when you can see an identifiable ring going almost 360 degrees around, that tells you that after settling, there's a real good chance that lens is just going to sink into touch, if not 100% of the way around, a good portion thereof. And what we're concerned with is that lens touching down on the peripheral cornea, possibly rubbing on the peripheral cornea and creating that staining. So anytime you see this thinning or this bearing through more than 180 degrees, you're going to want to call up the lab and order up a limbal clearance zone +5. You're going to want to increase the limbal clearance. As an example, you can see this ICD placed on eye, and this is the OCT image at insertion. We've got this vault that happens through the limbus in here, well out onto the conj before it lands itself down. But after 4 hours of settling, as that lens sinks into the conj, that average 125 to 150 microns, now we're seeing it starting to settle down on much more of the conj and maybe onto a bit of the limbus. So this is a case where we may want to increase the limbal clearance zone vault. Call up the lab and just order your custom order with slightly more vaulting in that area. Now it's really common to see in the central image with the patient fixated at infinity this thinning on the nasal side and the superior. And this has more to do with the slightly temporal, slightly inferior decentration we see in scleral lenses. When you see this thinning or possible touch here, and you're not sure, should I call up the lab and ask for a limbal clearance zone +5? Should I increase the vault +5? Well, have the patient do the fixation test, and all they do is change their gaze. We're going to have the patient look in the opposite direction to the bearing or touch, and it looks like on the nasal side we have this thinning. So we'll ask the patient to look temporal. When the patient does that, you notice how the lens skirts slightly temporal, and we get this beautiful vault on the nasal side. We also see this thinning or touch at 12 o'clock, so we'll have the patient look in the opposite direction, look down, and notice how that area completely vaults when the patient looks down. So this may just be a lens that's moving slightly temporal, slightly inferior, and it's come to a bit of rest down and out, and that thins out the fluid here. Now the question is this touch? And it doesn't look like it's anything more than benign touch, and it may just be thin fluid. So whenever you see this kind of thinning and you do the gaze change or fixation change and there's vault through that area, you know you don't need to worry about. But to be sure, have the patient, after a month of wear or a week of wear even, come see you in the PM. Remove the lens, stain the cornea, and if you have any desiccation there, if the lens has laid itself down on the surface of the cornea, then just call up the lab and order the increased limbal clearance zone. Now, why this temporal inferior decentration? It has to do, at least the temporal decentration, with the fact that the nasal surface of the sclera is much higher than the temporal side. On average, at Pacific University, we found the nasal side 320 microns higher in elevation than the temporal. So what does that mean? Our scleral lens drops toward the surface of the eye. It hits the nasal side first. It falls to the temporal side. The contact lens shifts slightly temporal, and that's what you'll see with most, if not all, of your ICD lenses. They tend to be slightly temporal. Most scleras tend to be slightly with the rule, meaning the vertical meridian is steeper than the horizontal meridian. Then we have gravity and lid force pushing the lens down slightly. So that's why it's not uncommon to see this kind of superior thinning and nasal thinning, because the lens is going slightly down, slightly out. So the rule is, with this limbal thinning, if it's less than 180 degrees, don't worry about it. Have the patient come back and see you for a PM visit with their custom lens. Take the lens off, stain the cornea, see if there's any desiccation. If there isn't, you know you don't need to change the limbal clearance zone. If after settling you're seeing this ring of thinning that's greater than 180 degrees, then you know right away we need to call the lab and order a limbal clearance zone +5 to increase the vault through this area and clear the peripheral cornea and limbus. So less than 180 degrees of thinning, not to worry. Greater than 180 degrees of thinning, order a limbal clearance zone +5. And you can see that here. We've got our standard trial lens on eye. It's got a very thin fluid layer, almost nothing. Probably through the slit lamp it would appear to be bearing. If we order from the lab a limbal clearance zone +5, that increases this angle, giving you far more vault through the limbus here. So limbal clearance zone increases that area under the limbal area of the lens. Now the last zone in the lens is the scleral landing zone, and this is where we'll often see in scleral lenses blanching of the vessels. We've backed up the vessel supply right at the tip of the edge, and this is usually caused when the lens angle is coming at far too steep a rate for the actual surface. So more often than not, we see the blanching when the patient's scleral angle is really flat, flatter than the normal design of the trial lens. So this is a simple problem to fix. By increasing the angle of this zone, we can create a better match of lens to cornea relationship. Now here, notice how the tip of the edge is pointing along the surface of the conge, and that gives us this beautiful looking image where the vessels supply their the vessels aren't restricted in any way across that lens edge. If we go back to this image, notice how the angle of the contact lens is pointing right into the surface of the conge. So this is where the angle is too low. It's effectively too steep for that eye. And here's a case where that angle is pointing well into the surface, and what that does is it cuts off vessel supply. So all you do is order from the lab a scleral landing zone -1 if it's a mild blanching, like less than 30 degrees or less than 1 hour on the clock face. If it's greater than 30 degrees of blanching or of any of this restriction of the vessels, then you'll go to scleral landing zone -2. So less than 30 degrees, order scleral landing zone -1 from the lab. Greater than 30 degrees, scleral landing zone -2. Now, why minus? Anytime you reduce sagittal depth in a ICD, it's a minus adjustment. If we increase edge lift in any contact lens, that takes away sagittal depth. It subtracts sagittal depth. So scleral landing zone -1 increases the edge lift and decreases the central sag slightly. Now, when you adjust that scleral landing zone, you do something in this neighborhood where the lens is pointing in, the tip is going into the surface. If we order scleral landing zone -1, we change that angle and the tip is pointing more along the surface, creating a much better lens to conj relationship. So with all the ICD family of lenses, the rules are the same. These are all ICDs, but these rules apply to all of the lenses. Number one is sagittal depth. If we put on a lens with inadequate apical clearance, we need to go to the trial set or custom order a higher sagittal depth lens to clear the corneal tissue. If we see greater than 180 degrees of limbal bearing or thinning, then we're going to order from the lab limbal clearance zone +5. If we have any mild amount of blanching, scleral landing zone -1 to increase the edge lift and create a nice relationship. So these are the three zones: apical clearance, limbal clearance, and your scleral landing zone. Now, we're really focused on fitting large diameter corneal GP lenses for patients with astigmatism or low amounts of asymmetry, and we're highly focused on fitting patients that are severe disease or severe asymmetry with the ICD or with a large diameter lens, a 16.5. The question would be, is there an in-between that we could do for a patient that can't achieve the comfort in a corneal GP but doesn't necessarily need a large vaulting scleral lens like the ICD 16.5? And that led to the construction of a 14.5 millimeter version of the ICD. This lens is basically a cut-down version of the ICD. All the zones are the same. All the thought processes and fitting methods are identical. The ICD 14.5 was designed more so for normalized than really highly bulging grafts. So if you've got a real pronounced corneal surface, highly tilted, then the ICD 16.5 is the lens. If you've got a high amount of corneal astigmatism, then the ICD 14.5 may be a good option. Smaller lens, easier to get in, easier to get out. Now, it's also a good choice when you have really small corneas, where you don't necessarily need a big lens that's going to land well past the limbal borders. And possibly the most common reason for failure in scleral lenses is not comfort, it's not fit. It's more often than not the patient can't master insertion and removal. So with the smaller 14.5, you may find that you're able to get it in and out easier on some of your patients that are struggling with bigger scleral lenses. Now, the ICD 14.5 has a fairly wide range of patients it can fit, not as wide as the 16.5, but significant enough that you can use it on a large body of patients. So anybody with astigmatism, eyes that are normal shape with ocular surface disease, it's a good choice. Refractive surgery patients tend not to be too tricky in that they don't tend to have high and low points that are asymmetrical in the surface. They tend to be relatively symmetrical, so in a smaller scleral lens they'll usually do just fine. Pellucid marginal degeneration, Sometimes you'll need a 16.5, but very often you'll be able to use the 14.5. If it's mild keratoconus, if it's not too advanced, the 14.5 can probably vault and accommodate those lenses. I put here corneal graft because we fit the ICD 14.5 on many corneal grafts, but only those that are relatively low in depth and without high degrees of asymmetry. When you've got highly elevated points opposite very low points, chances are you need a much bigger lens to vault those bulges in the eye surface. Now, as I said, the 16.5 and the 14.5 are absolutely the same in their construction. You have central clearance zone designed to clear the cornea, limbal clearance zone designed to clear the limbus, scleral landing zone designed to apply all your weight and pressure on the surface of the conj. So the two lens designs are absolutely identical in your thought process. You'll notice, however, the sagittal depths are slightly different. We have much lower sagittal depths, and that's because it's a smaller diameter lens. So if you have a normal cornea with ocular surface disease, if you have a patient with a high corneal astigmatism, but it's regular, if you have a post-refractive surgery patient in the ICD 14.5, you simply go to a 3400 micron lens. That's the normal sag lens for a low depth eye. If you have keratoconus, you're going to go 300 microns higher, up to a 3700 micron. If you have a corneal transplant, you'll go up even higher, right to a 4000 micron lens. Notice with the 14.5, very similar, each lens is separated by 100 micron increments, 3100, 3200, 3300, so on and so forth, all the way up. You'll also notice with both fitting sets that the powers correspond slightly with the sags. So this patient has, this lens is a 3100 micron sagittal depth. It has a -1 power. This lens is 3500 microns. It has a -5 power. So it's an easy way to distinguish between your trials which is which when you're throwing it on a lensometer, if you thought you mixed the lenses up accidentally. Now again, with the ICD 14.5, we're going to look first at the central clearance zone. And what we're hoping to see is a beautiful vault through the central cornea with an absence of any corneal bearing. If we place a trial lens on eye and it hits the corneal surface, you know you need to go higher in sagittal depth. If it's touching, you want to be at least 300 to 400 microns higher in height to make sure we clear the cornea. Now, similar to the ICD 16.5, the 14.5, you want to vault through the limbus. Now, you have less real estate to do so because it's a smaller diameter lens. There'll be less of the vault through well into the conj, but the goal is to make sure that you have this vault through the limbus, like you can see here. There's a little bit of fluid running onto the conj before the lens lands itself down. So again, the rules, as I said, are the same. Apical clearance, limbal vault. And just like the 16.5, we want our lens to land itself down on the scleral landing zone, making sure that the vessel supply through the lens edge looks normal, that the lens isn't going to seal off any of the vessels. So one of our principal observations after settling is to make sure that we don't see any blanching at the tip of the edge. If we do, we know we need to custom order a scleral landing zone -1 in mild cases, scleral landing zone -2 when the tightness of the edge is significant. Once you modify that scleral landing zone in your custom order, notice how the apex of the edge is pointing more along the surface rather than pointing into the surface of the eye. And what this does is it makes for a much more ideal lens-to-surface relationship where we're less likely to see any kind of blanching with this type of landing. Now, if you don't have OCT, That's okay. The slit map makes it very clear to see when we have blanching or no blanching. So with the ICD 14.5, consider apical clearance, having good vault through the central cornea. If you have a wide area of peripheral corneal alignment or touch, then you need to increase the limbal clearance zone. If you see any blanching, you need to increase the edge lift. So scleral landing zone -1 or -2, maybe even -3 if it were a severe case. Now let's actually fit a patient. Here's somebody with RK. We see the asymmetry of the eye. One can imagine the flare and glare that this patient might have, especially at night. We'll focus in on the right eye. And we'll place our 14.5 millimeter lens on eye. Notice slightly thin in here on the nasal side, a little thicker possible touch or bearing out here on the temporal side. So that's something we'll want to monitor, make sure that we don't have too small a lens on a big cornea, or post-removal of the lens, do we see any staining of that peripheral cornea? When we OCT, this lens went on eye with 270 microns. One can expect a similar settling with the smaller diameter scleral lens, probably 100 microns, maybe a little bit more. So always best to have slightly more fluid on insertion. Then here's the periphery. Notice how the lens touches itself down just at the limbus. So this lens has just cleared the limbus, placed more of its pressure just beyond. So this lens may just have been big enough to fit this larger cornea. And again, I'm reminded of that consideration that the 14.5 is a smaller diameter lens. It has less space to land itself down. So consider the ICD 14.5 on smaller corneas, not on larger corneas. Here's our left eye. Again, the asymmetry of the surface. Notice how within the pupil on the axial map, we don't really have a defined steep or flat meridian. It's more of a asymmetrical surface, so quality of vision very poor. We place on eye the ICD 14.5. Initial trial looks like the limbal clearance needs to be modified. It looks possibly a little thin. This is on insertion, so one can expect that dark ring here to deepen even more as that lens settles in. So this is a patient almost certainly needing the limbal clearance zone +5. Apical clearance on insertion, another 270 microns of fluid, so that would probably be acceptable on insertion. If it settles 200 microns, we might want to order from the lab a slightly higher sagittal depth or modify the zones in the lens to increase the sagittal depth. But your ICD consultant at the lab can assist with that modification. Now here we see with the left eye, the lens vaulting, maybe not quite vaulting to the limbus. There's a bit of pressure or touch with the lens here on the nasal side. On the temporal side, a similar thing. So this is a case where we might want to consider going up to the 16.5. If after settling that lens shows any staining of the peripheral cornea, then we would want to make that adjustment. Now here's why the smaller diameter lenses can be a concern. When we have this high elevation in the surface of the peripheral cornea or limbus, and this happens on patients with high scleral angles, they're effectively higher depth anterior chambers, then you may need a different lens design. Notice how this lens has this ring of bearing, or it's certainly very thin fluid there. Post-removal, you get the staining of the peripheral cornea. So we would order from the lab limbal clearance zone +5, maybe even +7 or more, to vault through this area. If we cannot clear this peripheral corneal elevation, then we would go up to the ICD 16.5 to make sure that we can vault that area. Now when you change the limbal clearance zone, what you're doing is is increasing this angle. If the blue is the standard ICD 14.5 or 16.5 limbal clearance zone, then if we needed more vault, like we see in this image, we have very little peripheral cornea and limbal clearance. If we increase that angle, we create more vault. So what you're doing is changing the angle to be more elevated to increase that fluid between lens and the surface of the eye. So each increment of the 14.5 and the 16.5 represents 25 microns of depth change. So the standard adjustment with the ICD 14.5 and 16.5, if you need more limbal vault, is to order from the lab limbal clearance zone +5, and that simply ramps up this elevation that exists through the periphery of the lens, keeping the landing the same. The landing angle stays exactly the same when you increase this limbal clearance vault. All you're doing is trying to change the amount of fluid between the peripheral cornea and the limbus and the back of the lens. Now, if you consider fitting the ICD on ICD 14.5 on a larger cornea, you're going to have to spread your bearing out across a bit of the peripheral cornea, and this is a no-no. So we try to avoid fitting it on these large corneas because we know it's going to be very difficult to clear the limbus. When you have smaller corneas, 11.5 and smaller, you have more room to vault over the limbus before you touch the lens down and land on the conj. So contraindications of the ICD 14.5, the smaller version of the ICD, is any kind of bulging cones or bulging grafts. We would avoid those because the smaller lens has less area underneath to vault over top of these high-depth eyes. The other consideration is stay away from corneas that are larger than 11.5. The 14.5 lens will manage your 11.5 and smaller patients, which is very close to the average visible iris diameter. So it's going to fit a wide range of eyes. Now within the ICD, you have these two great options. Now when the ICD 16.5 is too big for a patient to get in or out, you can go down smaller to the 14.5. If the 14.5 is impinging on a pinguecula, then you can go up to the 16.5 to try to vault over top of it. You have a bunch of different options now to modify both lenses similarly, so you treat the fitting of both lenses exactly the same. Apical clearance, limbal clearance, scleral landing, and the modifications to each in microns or angles are exactly the same. Now lastly, we're going to address the new ICD Toric, and we know that most eyes have slight asymmetry in angle and slight asymmetry in the elevation. However, because scleral lenses sink into the conj, they'll often eliminate any kind of asymmetry that exists. So, for instance, in a study at Pacific University, we looked at what was the average amount of depth differential between the horizontal and the vertical meridian. And if our scleral lenses, for the most part, hit down at 3 and 9 o'clock, how much would they lift at 12 and 6 o'clock? And the surface of the conj is about 150 microns deeper across the vertical meridian. Now that would indicate that when we place a scleral lens on eye, it should land at 3 and 9 o'clock and it should lift at 12 and 6 o'clock. But of course, scleral lenses sink into the soft conj, so it's going to compress and eliminate a lot of this fluid at 12 and 6 o'clock. So that's why you can usually fit a patient with a symmetrical scleral lens. You don't need a toric. Now when you look at this particular fluorescein pattern, do you see anything wrong here? And of course, what we don't have is the lens actually landing at 3 and 9 o'clock. It's completely vaulting over top. So this patient must clearly have a very toric scleral shape, because it's not common to place a lens on eye and not see it almost instantaneously seal itself 360 degrees around. And here was the problem. This patient had a highly toric scleral shape. And when we place the symmetrical ICD on this patient, notice where it lands at 12 and 6 o'clock. It vaults at 3 and 9 o'clock. You can see the patient's habitual lens where it was digging right into the conge. It actually had sunk itself, the tip had sunk itself completely in at 12 and 6. So did we do any better with the ICD on this patient? And the answer is no, we didn't, because it's such a toric sclera. We needed a toric ICD lens. And that's what's been constructed. So now you have the ability to make a toric ICD. It has one meridian of depth across the flat and a completely different meridian of depth across the steep. And now you see it actually landing itself down 360 degrees around, which is our goal. Landing at 360 degrees traps that fluid, avoids getting air bubbles in there, and in the ocular surface disease patient, that's what creates the bath that gives the dry eye patient relief from their symptoms. So when you place a standard ICD on a patient, and it does align 360 degrees around, you don't need a toric, but you have any kind of residual astigmatism, then what do? This is where the ICD toric is beneficial. And I hope this video will come through the internet, but what you see is an ICD toric on eye with its scribe marks at 3 and 9 o'clock, 0 and 180. As we rotate it off axis to 90 and 270 and ask the patient to blink, let's see if that lens comes back on to its appropriate pre-settling axis. And notice how it's continuing with each blink to move in the direction of where it started out as. So the beauty of putting a slight amount of toricity into your ICD lenses means that they can align well even on a slightly symmetrical eye, and a front toric can be placed on the anterior surface to correct any lenticular astigmatism. So in this case, we didn't use the ICD toric for a toric sclera. We used the toric for lenticular or residual astigmatism. But given that the eye has a very slight amount of toricity, the standard ICD toric often will sit on axis and lock itself into the same position. So there's two applications that we need toric sclerals for. One is for when we have a highly astigmatic shape sclera or highly irregular shape sclera, and the other is when we have a relatively normal scleral shape, but we're manifesting lenticular astigmatism through the lens. So we need the toric for both types of applications. The standard toric will have a mild amount of asymmetry in the periphery to keep it on axis, whereas a lens fit to a highly toric sclera can be almost any degree of toricity. So it's custom manufactured based on what you see with the trial lenses. Now, as you know, there are two versions of the ICD, the aspheric optic ICD and the spherical optic ICD. And you need to know which version of a set you have. Do you have the aspheric or the sphere? And you will therefore want to order your toric in the same construction. So for instance, if you have the ICD sphere, if you put on a 4500 sphere and it's tilting back and forth, it needs a toric, then you know I'm just going to put on the 4500 toric and it will fit similarly in depth. It should be the right apical clearance if the symmetrical lens had the right apical clearance. Now again, let's go back to, are the rules any different when we fit a ICD 14.5, 16.5, or the ICD toric? And the rules are the same. We start with the apical clearance. Does our lens clear the central cornea? Are we going to vault the central corneal tissue the same way we do with the symmetrical lenses in the family? If there's any corneal bearing, go up higher in the fitting set by at least 300 microns 400 is probably safe. So if we put on a 4200 and it touched the cornea, then we're going to go up to a 4600. Limbal clearance zone with the toric, we're looking for the same kind of vault through the peripheral cornea and limbus. If we don't see it, we want to call up the lab and order limbal clearance zone +5. Scleral landing zone, we're looking for that lens to land with all its weight and pressure out here on the conge without any sealing of vessels, any blanching of the conge. Now the one thing that is different is you have these rotation markers in the ICD toric. And although the patient's astigmatism might be 180, you don't know if the actual scleral toricity is flat axis at 180. So the toric ICD trial needs to be placed on eye to determine which axis does the lens sit at. Does it sit at the same axis as any corneal astigmatism that might exist? And my experience is the two do not line up very regularly. In other words, if you had a spectacle RX of -6, -3, axis 180, it's not common to see your scribe markers that find the scleral toricity. It's not common to see them lined up at the same axis as your refractive cylinder. So all you need to do is note for your lab, where are these markers lined up? Is it 0? Is it 10 degrees, 30? Where exactly are those markers? And then simply over-refract the same way you would normally do. With the toric, you're able to include the spherical cylinder refraction. You don't have to go for spherical equivalent, of course. We only do that in the symmetrical ICD lenses. So the rules are absolutely the same with the toric. The one thing that you might consider is you just need to add where are these rotation markers aligning when the lens finds its point of settling. Otherwise, you need to know, is it the sphere or the aspheric ICD toric? Is it the limbal clearance zone that needs to be modified at all? So all the things you look at in the symmetrical 14.5 and 16.5 ICD you look at in the toric, with the added the addition of the axis of the rotation markers. So the ICD family has expanded a bit from the original ICD 16.5. You now have the slightly smaller 14.5. You also have the ability to create a toric for astigmatic scleras and for patients with lenticular astigmatism. Again, I know many of you are from outside of Canada. If you're outside of Canada, go to the ICD website, Paragon's website, icdlens.com, and you can click here on Locate an Authorized ICD Laboratory and find a lab near to you that can provide the ICD lenses. If you're in Canada, then Precision Technology, based in Vancouver, is the place that you want to go to acquire the technology. So I'd like to thank you for joining us this evening for this webinar. I hope that you've found it both interesting and enjoyable. Any questions that you've posted, I will get back to you with an email within the next 24 to 48 hours, and you'll also be able to see any questions that others have had, and hopefully the responses will be a benefit to everyone. If you're within Canada, you can acquire the ICD, as I said, from Precision Technology Services at this 800 line or at this email address. So I welcome you to reach us directly if you're in Canada. If you're outside of Canada, again, go to the ICD website. Everybody, thank you very much for your time. I hope you have a great evening if it's evening where you are, or a great day if it's morning. Thank you very much, and I'll look forward to assisting if you have any questions.